Energy is energy by a single element. The amount of Assalamualaikum and good day. Today we will present about photoenergy, photoconductive effect and photovoltaic effect. What is photoenergy? Photoenergy is energy carried by a single photon. The amount of energy is proportional to the electromagnetic frequency of the photon and inversely proportional to the wavelength. If the frequency of the photon is high, its energy will be high. Hence, if the wavelength of the photon is longer, the energy is lower. And the photon energy is expressed in the electrovolt EV unit and the joule. The photon energy formula is E equal to HF, which is E is photon energy, H is Planck constant, F is electromagnetic frequency measured in Hertz. This is for a single photon, and when for photon to be emitted, consider n number of photons. So the new formula is E equal to NHF. Energy is calculated in joule and electron volt EV depending on the system of the unit used. So 1 joule is equal to 6.24 multiply 10 power of 18 electron volt. For radius like gamma ray, the large unit have represent the photon energy with higher energy and frequency. Wavelength and frequency are interdependent parameters. The equation for the energy contained in a photon is given as follows: E equal to Hc divided by lambda, which is E is energy of the photon, H is Planck constant, F is photon frequency, lambda is photon wavelength, and C is speed of light. The photon energy at 1 Hz is equal to 6.626 multiplied 10 power of negative 34 joules, and the Planck constant is term of EV is 4.14 multiplied 10 power of negative 50 EVs. To find the photon energy is electron volt using a wavelength in micrometer, the equation is E equal to 1.2398 divided by lambda mu m. The equation only apply when wavelengths are measured in picometer. When the photon energy at the wavelength of 1 mu m, the wavelength of near infrared radiation is approximate 1.2398 eV.
Photoconductive is a type of semiconductor that increases its electrical conductivity when exposed to the light. This is due to the explosion of photons, which causes the movement of electrons from the valence band to the conduction band, resulting in increase in the number of free electrons available to conduct electricity. Photoconductive materials are commonly used in sensor, detector, and electronic devices such as photocopier and scanner. For example of photoconductive is material in silicon. When silicon is exposed to the light, its electrical conductivity increases, allowing electrical current to flow through it more easily. This property of silicon is used in many electronic devices, including photodiodes, solar cells, and capacitors. Photoconductive materials are commonly used in applications such as sensing, imaging, and solar energy conversion.
Next, I will explain about photoconductive effect. Photoconductive effect is the alteration of electric conductivity produced by the absorption of varying amount of electromagnetic radiation composed of photon. The photoconductive effect is the result of several processes in which photons cause electrons to be ejected from the valence band and injected into the conduction band, resulting in increased electrical conductivity. The increase in conductivity is caused by the additional free charge carrier generated when photon energy are absorbed in energy transition. Next, I will explain about the application of photoconductive. Photoconductive usually used in LDR, or also known as light-dependent resistor. LDR are useful in light or dark sensor circuit. Normally, the resistance of LDR is very high, sometimes as high as 1 milliohm. But when they are illuminated with light, the resistance drops dramatically. The animation shows that when the torch is turned on, the resistance of LDR falls, allowing the current to pass through it.
Photovoltaic. Photovoltaic is direct conversion of light into electric power using semiconducting materials such as silicon. Photovoltaic therefore means light electricity, describing exactly the photovoltaic phenomena where you can directly convert light into electricity. So solar panels are using this phenomena to supply green power for home and industry. And fortunately, the cost of solar panel is on the decline, making the technology more available. So next, for photovoltaic effects. The photovoltaic effect is a process that generates voltage or electric current in a photovoltaic cell when it is exposed to sunlight. It is this effect that makes solar panel useful, as it's how the cell within the panel converts sunlight to electrical energy. The photovoltaic effect was first discovered in 1839 by Edmund Becquerel when doing experiment involving bad cells.
The photon effect occurs in the solar cell. The solar cells are composed of two different types of semiconductor, which is p-type and n-type. They are joined together to create a p-n junction. By joining these two types of semiconductor, an electric field is formed in the region of the junction, and electrons move to the positive side and holes move to the negative end side. This field causes a negatively charged particle to move in one direction and a positively charged particle in the other direction. Light is composed of two photons, which are simply small bands of the electromagnetic radiation or energy. This photon can be absorbed by a photovoltaic cell, the type of cell that compose solar panel. When light of a suitable wavelength is incidence on this cell. Energy from the photon is transferred to an atom of semiconducting material in the p-n junction. Specifically, the energy is transferred to the electron and in the material. This causes the electrons to jump to a high energy to the high energy state known as the conduction band. This leaves behind the hole in the valence band that the electron jump up from. This movement of the electron as a result of added energy created to charge carrier. An electron hole pair. When unexcited electron hold the semiconducting material together by the forming bond with a surrounding atom. And those they cannot move. However, in their excited state in the conduction band, these electrons are free to move through the material because of the electric field that excites as the result of the p-n junction. Electrons and holes move in the opposite direction of the aspect. Instead of being attracted to the p-side, the free electrons tend to move the n side. This movement of electrons creates an electric current in the cell. Once the electron move through this a hole that is left. This movement of electron creates an electric current in the cell. Once the electron move, there's a hole that is left. These holes can also move, but in the opposite direction to the p side. It is this process which creates a current in the cell. A diagram of the process can be seen in the figure at the right side.
Use of photovoltaic effect. There are three use of photovoltaic effect that I choose, which is solar panel of International Space Station, and second is photovoltaic study shade is an autonomous and mobile station in France that provide the energy for electric car using solar energy. And for the third is the solar settlement, a sustainable housing community project in February, Germany.
In conclusion, the maximum kinetic of photoconductive at the metal surface is the difference between the energy of the incident photon and the work function of the metal. The work function is the binding energy of electron to the metal surface. Each metal has its own characteristic work function. While the photovoltaic effect can be defined as being the appearance of a potential difference between two layers of a semiconductor slice in which the conductivity are opposite.